Welcome back. This is Mr. Hassan's Maths channel, and this is question number 3 now from the June 2023 Pure Mathematics P3 exam. We have a question. Part 1 is all about differentiation, as is part 2a, and part 2b is about integration, and they're all kind of related in a way, as we'll see. So first of all, it says find the differential of ln of sine squared of 3x with respect to x, writing your answer in simplest form. So here we have something that we have to differentiate in the form of the ln of something. The ln of something. Now when you differentiate something in the form of ln of something, then you always have 1 over that thing as it is, and then multiplied by the differential of that thing. So the ln of something always differentiates in this form. So for us to differentiate this, we're going to write 1 over whatever's inside the function, which is the sine squared of 3x. And then we have to multiply by the differential of sine squared of 3x. Now, the sine squared of 3x is actually the same as saying the sine of 3x all squared. That's what it means. Okay, that's how it's written like this, but this is what it means. So when you differentiate something like this, you multiply by the power. So you're multiplying by 2. Then you have the sine of 3x raised to the power of 1. You take 1 from the power. But that's not enough, because this is something of the form of something which is raised to the power of something. It's a polynomial type of, power function. When you differentiate that, when you differentiate something like this, then you multiply by the power. You take 1 from the power, which we've done, but then by the chain rule, we multiply by the differential of what's inside the function. So we multiply by the differential of sine 3x, which is going to give us, it's going to be cosine 3x, but then again, we have to multiply by 3 because there's a function inside that function as well. So there's a few different instances of, the chain rule here. So you end up with 3 cosine 3x when you differentiate sine 3x. So now we want to simplify this. So we have 2 times 3, which is 6. And we have sine 3x times cosine 3x over, and we have sine squared 3x in the denominator. Now, one of the sine 3x's will cancel out here. So you're left with 6 times cosine of 3x over just 1 sine 3x, not sine squared 3x. And we know that the cosine of an angle divided by the sine of the same angle will give you the cotangent of the same angle. So 6 times cot 3x. And there is the answer to 3 part 1. So it's just a question of applying the chain rule a few times here. And 2 part A is almost the same kind of situation in terms of we have to apply the chain rule. So we have something raised to the power of 6. That's the main function here. Inside the function is 3x squared minus 4. So to differentiate this, you multiply by the power, and you take 1 from the power, and then you multiply by the differential of whatever is inside the function. So I'm going to, first of all, multiply by the power, so I have 6 times, then I have 3x squared minus 4 to the power of 5. So multiply by the power, taking 1 from the power, then I multiply by the differential of what's inside the function, which is going to give us 6x. So I end up with 6x times 6, which is 36x. And you're left with 3x squared minus 4 to the power of 5. So there's the answer to part A. And then for part B, it says, hence show that the integral of this is equal to R. So hence means using your result that we got now. Now, if we think about the result that we got now, you can see that when you integrate, if you integrate 36x times 2x squared minus 4 to the power of 5, we end up with 3x squared minus 4 to the power of 6. It's like the reverse, right? So if we're starting off with something which is, less, we got x, it's almost the same as this, except it's multiplied by 36. So our result should be basically 1/36 of this result. Okay, so what we can say is that this should give us, we should end up with 1/36 of, whatever our original answer was, or the original question was. Because when you're going this way, that's integration. When you're going that way, that's differentiation. So if I integrate this, I should get that. So if I integrate something that looks almost the same as this, okay, except it's 36 times bigger, I should get 1/36th of my answer. So this should be 1/36th of the actual original question, which was 3x squared minus 4 to the power of 6. And that's between 0 and root 2. So that's the way that they are intending us to answer this question. I mean, in general, how I would answer a question like this, if they didn't say hence, is I would say, okay, I can recognize that I can reverse the chain rule here, because outside of the function is the differential of what is inside of the function. I can recognize that I have a function, okay, and what's outside it is the differential of what's inside the function. Okay, so I have g of f of x. Okay, that's like inside the function multiplied by f dash of x, something like that, right? So that's a better way of writing it. Okay, so I have outside the function the differential or something of the same type of the differential. If I differentiate what's inside it, I get 6x. Outside, I've got x. So it's the same order. So what I would do is I would say, okay, I'm going to write it as it is, except I'm going to start integrating it by, in this case, raising the power by 1, then divide by the new power and by the differential of what's inside the function, which is 6x. Now this x will come to with this x, I'm left with 1/36 times 3x squared minus 4 to the power of 6, which is exactly what I've got there. So that's how I'd normally do it. But because I say hence, it means that you've got to use like a pattern that you spot between these two. So you could just write the answer straight away. And now we can put in the limits. Okay, now we have to put in the limits and find the value of r. So r is going to be given when we put these limits in, which is going to be 1/36. I'll leave that out here. And I'm going to put root 2 instead of x. So that's going to be 3 times root 2 squared, which is 2, minus 4. That's raised to the power of 6, minus, and then I'm going to put 0 instead of x. So it's going to be 3 times, that's going to be 0, minus 4 to the power of 6. So I end up with basically 1/36 times, that's going to be 2 to the power of 6 minus 4 to the power of 6, which will give you a positive answer. So what does that give us? Let's have a look. We're going to have 1/36 times 2 to the power of 6 minus, and I don't need to put the negative here because it's going to become positive because it's raised to an even power. So minus 4 to the power of 6. And that gives us our answer, which is negative 112. So, oops, negative 112 is our answer. Negative 112. And that's the answer to this. They're not saying find the area of anything. It's just asking you to give the value of this integral. This is the value of the integral. If they say find the area of the curve, whatever, or something like that, then you wouldn't in the end write a negative area, you'd write a positive area, but then you'd also have to check to see if there's any parts above and below the axis or whatever. But in this case, we don't have to do any of that because they're just simply asking you find the value of this integral, not related to any area or nothing. It's just said find the value of this integral, so that's perfectly fine. And that answers part B of this question. All right, pretty straightforward question if you're well versed with the chain rule and also integrating by reversing the chain rule, sometimes called integration by recognition. Right, so in this case, they are kind of forcing you to do that and not use some sort of substitution method, okay, because they're saying hence. Okay, a few little things that were extracted from the examiner's report for this question. One of the things were some people just wrote the answer down, meaning they just put this into their calculator, which you can do, okay, and I'll show you how to do it, but without showing any of these steps of integration. If you did that, you won't get any marks for it, but it is a good way for you to check. So we could do this to check our answer. So you have x, and then you have bracket 3x squared, so use this x button here, 3x squared minus 4 to the power of 5, okay, and the limits are from 0 to root 2. And it should give you the answer, which it does, okay, but if you just wrote that answer down, you will get no marks. But if you did this to check your answer, to make sure after you've written down your steps, it's fine. Now they mentioned here, some people try to use substitution, which is possible. Some people reverse the chain rule, again, like I did here. And some people just use the fact, which is what was intended, use the fact that we already got that result. Okay, so we've got this answer here, and we can just, kind of like just reverse that. Okay, so that's how they intended you to answer the question. But they gave credit for those other methods as well. Okay, like if you use substitutes and stuff, but it just takes you a lot longer, that's all. And they mentioned also that some people wrote that they didn't write the negative sign, and as long as they saw the negative sign before, they let you off if you didn't write it. But you should keep it, because they're not asking us to find the area. So there's a few important points that you can extract from the examiner's reports that will help you to learn the type of things that will lose you marks and the things that the examiners are looking for. So it's very useful to look at the examiner's reports, okay, about these questions. Anyway, that's the end of this question. Question number 3. Other questions from this particular paper, this June 2023 P3 paper, can be found in the playlist. It will appear in this region over here. Other questions from this topic of differentiation, P3 differentiation over here, and P3 integration. I'll put a separate playlist over there. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.